Ik wil nog niet heel veel lawaai maken, zodat het fotograaf dat het leuk is, dat je extra niet kunt doen. Toch de micro aansluiten. Voilà, dus we moeten beter in de huidskwaliteit zijn. Dan denk ik dat we kunnen beginnen. So today is the last session, the last contact moment for the BIT04, the R course. So what will I discuss today? I will talk about the chapter 4, Packrat, ggplot and other packages. Other packages in this case are packages that you can use to connect to a database. And then I will talk about R Markdown and very briefly about Shiny. And on the R Markdown, I will tell you more how you can, if you already started with your project, how you can use that code to copy it into your R Markdown, and we'll be able how you can generate a report, a PDF, for example, that you then have to submit. When do you have to submit your assignments? I think the day before the exam. So 26th of March, so that I can check then the next day if all the submissions are correct. When you come to the exam, then I can still say there's a problem with your submission. So you have to submit it the day before the exam. And in the project assignment, you can actually read more. So you'll have to upload 2 files. One is actually the code. This can be an R file or an RMD file. So RMD, I'll talk about this today, is specifically an R Markdown. And then actually how the output is, the report, the result. So this is then either an HTML file or I prefer actually a PDF. But normally if you would provide me with either or both, I can of course, if I have the code, be able to rerun it on my computer. So the minimum lines 150. Don't be afraid. Once you start working with R Markdown, you will easily get to those 150 lines. So no problem if you don't have enough lines yet. You will easily get those number of lines, as you will see later this evening. Maybe I'll also record the session here. So also have a screencast. So the project uploaded the day before the exam, the latest, or of course a bit earlier. And now I will start with the Packrat. What is Packrat actually? It helps you manage the dependencies of all those R packages. Because it can sometimes be quite frustrating in R to work with these packages For example, let's say you've written a script this week, an R script. Could be if 1 year later you want to run the script again, but you've written in the meantime other scripts, installed new packages, updated some packages, that 1 year later there's a problem with your script that it cannot run immediately because there are problems with the packages that you need to run the script. So Packrat can actually handle that. If you normally install a package in R, it is installed on your system, for all users also. Packrat can actually manage and contain a folder, let's say, specific versions of those packages. Which means if today you would write an R script, you use Packrat, you install certain packages you need, and you work within a project, that 1 year later, you open your project again with Packrat also attached to that, you will use those packages, those versions of those packages, and you should be able just to immediately run your script again. So that will help you deal with the dependencies and updates of packages. Once it works for your R script with certain versions of packages, normally it should be able to work in the future if you work in a project and you combine that with Packrat. So the first thing, of course, that you will have to do is install Packrat and then, of course, use the library. Now, I think for now you don't have to use that. If you used libraries so far and they work, just don't do any updates before the exam, right? Certainly not the day before the exam. Start updating your system, because this may break a few things and then you could have a problem on the exam. If you want to work with Packrat, how is the way to do it? You actually don't open a new file, but you start by opening a new project. Then you choose a new directory where also the packages will be installed, specific versions of the packages. You start a new project, you look for a directory, you can locate it here, and then it's important to use Packrat with this project. So if you select this, then you will be able to use specific versions and store that in that directory. It's also possible to combine this with a Git repository, but I would advise them to use this Packrat. First time you install it might be that you have to restart your R, so after the installation, before you see this, might be that you have to restart your R again before then next time you start your R, you will see this option. So I have an example on the learning environment of BIT07, because last year it was BIT07 and not BIT04. And that is actually a Packrat folder that you will see and a project then with certain files. So you could open that one and have a look then how that works. What will be the difference is that you will have a specific Packrat library. So if you would go in your R to packages, then you will see that you will have a separate library with packages on a specific version, which you normally won't have. If I would look here, in my package, I just have my user-specific library for my operating system, and then my system library. So by default, when I install RStudio, I have the system library, and then these are the additional packages. So if you combine that with Packrat, you will also here have this Packrat library available. And then in this case, you could add other packages like the ggplot that we'll use today, and then here you will see in your Packrat library all these packages, and here that specific version you work with. So it could be perfectly that if you close this project and you start working again, that you could actually work with different versions of packages. But 1 year later, you open this again, and you can actually again use these versions of the packages you need for your R script when you developed or wrote your R script. It's also possible to do some actions. For example, take a snapshot, and then you see here also in the snapshot which version of packages you are currently using. To have a look at the status and restore. For example, it could be that you don't need certain packages again. So for example, this one here you see are used in your code, tracked by Puppet, but no longer present in your library, then it could also deal with this. So this is when you run this command here that you will get this information. So that is if you want to freeze, let's say, certain versions, have more control over an R script in combination with certain version of packages, I would advise you to use Puppet. Next is the ggplot. This is actually very popular. Probably you will recognize some of the plots that are generated by this ggplot package. First I want to tell you that you can also, if you need more information, of course you can search online, but some developers of R packages, they also create a vignette, it's called, which tells you much more information about the package, some examples. Not all packages come with vignettes. For example, here you see a difference. ggplot2 here, then you will see here package vignettes. While for this package, this is one we've used before, the hwhisk package, there you don't see any vignettes. So this is actually more an extensive manual, you could say, documentation about that specific package that you can use. You can also, of course, find that online. This is, if you go to your packages, if you click on this, you will find these screenshots. But you could also go online on the R project website, look there for a specific package like ggplot, and here you will find the vignettes with much more information and examples of how to use this. Also here for another package, and for example here for this one you don't find that. So you don't have any vignettes in this case. Here for example, usage examples, always very useful to have a look at these if you want to do something, you don't know how to do it, to copy paste maybe the example and then modify it to your needs. Now what exactly can you do with ggplot2? First of all, it's a powerful graphic system, actually similar as you've used before if you just make an ordinary bar plot or a histogram in R. Then you actually use the base graphics, what we call, which is available within, when you install R, these actually are available. While ggplot2 is actually, let's say, more advanced, more powerful and flexible, so it's a different way of making graphics in R. First of all, they always use data frames. So, and you will see that most of the data you will have, it are just rows and columns, right? So you can actually always use data frames for this. And then the way actually how it works, how it is different from the base graphics is the GG and the ggplot actually stands for what they call grammar of graphics. And this is also represented here in this figure, where you actually see different layers. So each specific, what we call a building block, is in an independent layer. For example, you have your data, you have what you call your geoms, you have your coordinate system, and all of these, you combine these different layers, and this will actually create your plots. So these are the different layers, and you will need this grammar of graphics to get to your plot in this way. So what are the different building blocks that you can have? Of course, the data is a building plot, is a layer that you see here, then the aesthetic mapping, which I'll talk in a few moments. Then the geoms is actually a geometric object, can be a line, a data point. The scaling you will use, the scales, x, y, the coordinates, and some other things. And also position adjustments. That is also all a separate layer, a separate building block which you can use. Now what is exactly this aesthetic mapping? Aesthetic mapping just means that you can add something you can see. So it's actually a combination then of these geometric objects which have these aesthetic properties. So what could a property be? A data point, for example, can have a certain position in the plot, a certain color, it maybe has a certain size. For in this case, for example, you see a bubble chart could have a different size. Maybe you are using as geoms lines, then you can have a dashed line, a dotted line, a normal line, several other options for your line type. That could be another aesthetic property. So the geoms are actually the visual elements, so points, bars, lines, and so on. And those are controlled by these aesthetic properties like color, shape, and so on. How can we then use the variables? These are actually specified in what you will see AES, referring to the aesthetics. And you can use this in two ways. You can actually directly use it in the ggplot or in one of the layers. And I'll explain that with an example in a moment. Now there are actually several ways of using the ggplot, and you have several objects that you can use. If you want to see the full list of the objects, you can either use this command or look at the documentation if you go to the packages. And then of course you could search for ggplots here. Then click here, and then you will of course have here package vignettes and all the information here what you can use. So here the geoms, for example. So you can already see what is all possible. Maybe just show a few ones. Here, if you want to make a box plot, so these are the things we also did in the basic graphics. A violin plot, for example, just points if you want to make a scatter plot. And you see you have several more options. This was in the base graphics how we made our plot on the iris flower data. So we just used plot and then the two variables we wanted, so on the x and the y axis. This is actually how you do it in ggplot. So you use the ggplot function, you provide it with the data, iris data. So this is your first layer, and then actually you add your data points. So then you go for the aesthetic mapping. So you see here, I talked about this here, AES, and then you specify X and Y, and this is being mapped on your plot here. So either you can add it here, or you could also directly add the aesthetic mapping here in your ggplot. Then of course you don't need to do it here a second time. So these are two different ways of adding this. Either directly the first time in your ggplot function you call, or you could just do it in your layer of your geom object in this case. Both will work. And then what you actually see the difference is this is a totally different view. Maybe you've already noticed in some publications or online websites that you find this typical, for example, the light gray background. In the way of visualization, normally you will easily recognize if it was made the plot in ggplot or in another way. So it creates a coordinate system here, and the first argument is the data set, and then actually each layer is added with a plus. So in this example, I only added one layer here, plus and a point, but you could add more layers. So you will see that on the other examples. That here, for example, you could add geom smooth using the LM method, linear modeling. This will actually make sure you have here this line. That this is being modeled, calculated with a formula, and then you have that line. So again here, the plus, and you have a new layer you add. What it did here, which is different with the method before, is here I actually first create using the ggplot plot 1 or a bit point, and then afterwards I can also combine this. So plot 1 here, add the points, add the smoothing. So that is also a way of working and creating a plot in this way. Sometimes it's a disadvantage that it already does quite a lot. And it's quite nice, the view, the default view. But could be that you have to actually hide something. For in this case, for the line here, normally you don't have, you have the smoothing line, and then here you have the confidence interval here. So by default you don't have that. In this case, if you would want it, you will have to hide it. And then sometimes you will have to look, I don't want this, how can I change this? So then it's important that you learn how to work with the help, of course. So I hope you already used this the past weeks, that for anything you want to use, you can just have a look here. And then, for example, if I want to use something, maybe have a look here at an example. If I would want to use the, of course I have to load the package. And then the geom, I could just have a look here, curve density, here, what all the options are. Then you see here for all the arguments. So in the example shown here, in this case you were using the geom smooth. You type here in the help the geom smooth, and then you have a look at the documentation, and there you'll see the usage. Here, the SE option, display confidence intervals around smooth. True is actually the default. So this means if I want to have this confidence interval, I have to set the SE to false. So that's important to get to a higher level of working with R, that you have a look at the help, at the documentation, read it, be able to, especially for ggplot, for these advanced settings, that you are able to read this and then use it in this case. For example, turn off the confidence interval. This is actually a nice representation of how you can use it. An example, so here you see you call ggplot, use the data, aesthetic mapping, and then here the other layers you want to add. Each time put a plus. So I want to add data points, I want to use the smoothing to get the line, I want a Cartesian coordinate system, I want to use, for example, a color gradient, and this is then to change the theme. So you have several themes that you can use. So in this case, I want a theme with, I think, a white background in this case. So to turn off the gray background, you can, for example, add theme underscore BW, and then this will change your background. So this is an overview of some of the things you can do, but you can already see here the dots, so you can actually do much, much more. Then it's, you will just have to either look online or have a look in the help to find out more about it. So there are quite a lot of options. So this is just a small summary of what you can use. Points, box plots, labels, for example. You can change the positions of things. You can add also, of course, the lines, if you want to add reference lines. Titles, the limits, labels on X and Y axis. So these are also separate layers that you can add. Coloring and so on. So what is available, and also this is nice that you can change it to a certain theme. I will come back to that later. And then if you want to use a data set, this is actually a data set of the online resource that I mentioned for your project. So it's this one here, the R data sets. So if you go to this index here of all these data sets, you might see that, for example, here I would refer to the library robust base. If I search on this page, I find here the robust base package, and these are actually all the data sets within this package. So now, for example, if I want to use the Chrome D data set, I could just install the robust base package and directly call the data for the Chrome D dataset. So if you would choose a dataset from this list for your project, it's very easy actually to load it. Just install the package name or use the package name in the first column to install it, and then the second one is to call the data. So this is what is done here. Install the package robust base, you load the library, and this is then how you get the dataset. So probably now those of you who already started, downloaded the CSV and then loaded the CSV, right? But that's good for you to practice. So you could actually also do it in this way, which is actually easier.
No, that doesn't set with me from this site.
Okay, yeah. Maybe from Kaggle or another source, yes. So in this case you ask for the structure, first 5 rows, so you should know how to use this by now. And then let's say we want to use a bar plot. How do we do this? ggplot, the data set, the aesthetic mappings. We want to use the country column. We put that in BP1 assigned to bar plot 1. And then we add the geom bar. And this is quite special because actually the geom bar will already use this here to calculate. So we will already get a proportion for each of the groups. So in this case here I have country 1, country 2 I think, C1, C2. It already calculates the percentage here, or the number, the frequency. So this is immediately done by the geom bar. So actually this is a very fast way of generating a bar plot. And then of course you could color it, split it up further. So in this case what we do is geom bar aesthetic fill by the sex. So and then here you see the gender. So then we get actually a stacked bar plot, and then here we get a legend. What now if you don't want a stacked bar plot but grouped next to each other? You look into the help, and there you will find for the geom bar you can set the position, and in this case this is called Dutch. So if you set position to Dutch, you will no longer have a stacked bar plot but a grouped bar plot with country, and then here the genders indicated by the legend. So then this is just actually, you see, only like 2 lines of code. If you want to further modify it to have something like this, what did I do here? The X label set to country, a new layer here. Next one, the Y label, frequency by gender, here. The title is GG title, countries and genders, here. And then theme with a white background, you see the difference here. So here, for example, what I think is a disadvantage, if you would prefer the title then to be in the middle, because default here it is outlined to the left, then again you might have to change that, right? But with the base graphics, it's immediately in the middle. So that I think is an important setting that I also want to tell you. For example, that one then is here. So the last layer here would be theme, plot title, elements, text, horizontal just 0.5, and that will put your title in the middle. So this again is then what I think is a disadvantage, that you have to add this just to get it in the middle. Then Y limit here is an extra one, and then this is then to set the legends. Because here by default, you might have noticed, I got here Chrome D for the data set, $6 then for the column, and then by default, within the column, it shows MF. Maybe the person who has to read the plot doesn't know what MF is. Now, in this case, it's easy, but in other cases, not. So then you could just replace this here. So the name then would be gender, which is shown here instead of Chrome D $6. The breaks are what is found in the column M and F, and you just use then the labels. So the M will be replaced by male, the F will be replaced by female. So this I think is then already a better view in this case. And then white background, and you again put the this here, the title, in the middle. If you want to know more about the legends, because sometimes that's important, I've added here a link to the cookbook of R, specifically here graphs, legends, or ggplot, but you can also find more examples in this R cookbook if you would need it. And then another example, a histogram. You will see then that this is called geom_histogram. So this is then the layer. We use the Chrome D datasets, aesthetic mapping. We use the BMI, body mass index, and then we draw a histogram in this case. This is the default. If you want to change it a bit, you look at the documentation and the help for geohistogram. Then you will see that you can change the bin width. This is to use width of transparency, and then you could also add a color. Get something like this. A label, change the axis, the limits from 10 to 50. For example, here from 10 to 50. Well, here you see it's a bit different. And I also add geom density to show the density line in blue color, like this. And again, white background. So it will, take some time to look into the documentation. Often it's quite easy to get a default plot, but then to modify it, of course, it's a bit different than the base graphics. So just look into the help for what you want to do, and that will give you some more information on the parameters here, the settings that you can set. And then the last example, of course, is a box plot. This is a default again. Aesthetics, the treatment here versus what is NRAD again? The number of adverse events in this case. So this would be the default, already quite a nice plot, I think. Maybe nicer than the base graphics. If you want to change it into something like this, I use the R color brewer, and then here box plot you will see you can set fill, you can set color. For this I use 3 colors from the brewer palette set 2. These 3 colors make it a bit transparent, alpha value of 0.7, and then change here, for example, scale is discrete name treatment here. So this again is then specific, of course, for the box plots. The name, number of adverse events here. You could add some breaks. So the breaks are start from 0 to 4 to increase them by 2 here. Each time add 2, and then the limits actually, of course, then are these values combined from 0 lower limit to 14 upper limit. The title, and then this we already did here. Again, the title in the middle, and then here another extra option. Sometimes it's useful to add some more margin. So we did this differently in the base graphics. In ggplot, actually what you do is plot.margin, margin, and then this is here each time the centimeter that you can specify. So that is the last example. So this is just some examples of how you can make similar plots as in the base graphics, how you can do that in ggplot. So I don't know if this is easier, you find this easier than the base graphics or not? Yes. Yeah. So often people choose to either work with ggplot or just work with the other one. So I want to show you both, and then you can actually choose. On the exam, I will always show you what the result should be, so you know which one, of course, you have to use, but later in the work field on your job, you can, of course, choose if you want to use the base graphics or the ggplot. But this is quite popular in bioinformatics, the ggplot too. Okay? And then a bit further, what is, I think, very nice about the ggplot is maybe show what the problem could be. This could be the problem. You have lots of data of, in this case, 12 samples, and it's hard to have a look at one plot. So you already know you can make several other plots. This is actually quite nice and easy to do in ggplot. You can actually use the faceting technique. So what you then create is what we call small multiples. Same kind of plots in like a graph or a grid system. So these are the two functions you can use, the graph or the grid. And you can get similar plots with, for example, one sample in each plot. So this makes it much easier and better actually to look at the data. So in this case here, we just generate some data to use. And then this is actually how we use the faceting technique. We use the data frame, we use measurement and values, we use the geom line because this is a line that we want to plot. And then you can immediately use the facet graph on the samples. And then say also how many columns you want. So in this case, 1, 2, 3, 4 columns. If you only want 3, you could set here 3, then you would have more rows, of course. So this is maybe a bit easier than you have to refine rows, columns, and for each plot, write that code in the base graphics. So this is quite easy in ggplot in this case. If you would want points, then you just use geom points, and it's similar as there. Facet graph samples, columns, then it could look something like this. Also, you don't have to care much about the colors. Here, automatically, in the aesthetic mapping, you can actually define how you want to color. So if you want to color by sample, it will automatically use a certain color for each sample and add that here in an index. So also very nice to do that. But then of course you might have a problem here if you have lots of data points. You want to know more about the data points. So you want to add a label to a data point. For that you have a specific package that you can use in combination with ggplot. It's called ggrepel. It stands for repulsive text and label of the geoms. And what it can actually do is you can just replace your data points, either add the labels, but you can also, for example, here now we can't see anything, so this is marking or labeling each data point, of course. This is not clear to have a look. So there are then other ways you can actually use repel to more spread these labels. This is actually what this package does. So here you use the facet wrap, but you also use the geom text repel. Then you will see it will try to spread the labels, even add a line. So it is already a bit, of course, there are lots of data here, but it's already easier to see where a certain data point is, I think. And then you can further add several other things. For example, here in your label repel, if you would add these lines of code, you could see, you could add some boxes and visualize it like this. So this could help to identify where a certain data point is. For example, in this case, I would immediately know what an outlier or what the ID, for example, of the outlier is. So that's it for ggplot. So ggplot, the faceting, and then the repel. This is then an exercise for you to do. With the ggplot, you can actually create a plot like this. So here I specify what you need to do to get to this kind of plot. First of all, which color brewer palette you should use. That you should change main title and axis label. But this is actually where the power is to change the general layout. You can actually install another package called ggthemes. And this already contains quite a lot of specific views of how the layout visualization will be from your plot. So in this case, this plot was made with the economist theme. So install this package, have a look at the documentation, and then you will see how you can use a specific theme. And if you then will use this economist theme, you will easily get this kind of plot. Of course, I've adjusted the title here in the center, and I use the plot margin of 2 centimeters that I have quite some space around the plot. So normally if you all include these, you should be able to get a similar plot like this. So that's it for the ggplot chapter. Then the next one is databases. Now for databases, normally the students also have to install a database locally. But I think for you, with the last week before the exam, I think for you the most important thing is that you are able to communicate with R with an online database like the UCSC database. So this is what you should be able to do. So I'll just tell you which packages you need, but the local database you don't have to care about that. You probably already had the database course, or not?
That's the next one.
Yes. So that's actually why I can't also ask that from you, because you still need to have that course. So normally there you will learn more about MySQL. So that is why I will just briefly give you an introduction. This is actually, if you would want to install a database locally on your Fedora system, you start your HTTPD, that's the server, and then these are the packages that you will need to install to work, for example, with MariaDB is actually a fork from MySQL database, and then you could actually run your own database on your Fedora. But this is then for a later stage. Then some more information about how you can download the database, for example, and import that. But for you, I think I will skip to the moment where you can actually connect to an online database. That I think is very useful for you. So let me skip all of this, and I won't ask this on the exam. So this is how your local database would look like, but I will not ask you to do that. The only thing that you will have to do is you will have to install the DBI package. This is what you will have to do. And then the MySQL. And then you should be able to connect. But maybe I will skip all of this and just show you in the example code what you should do or be able to do. And so if I open BIT04-R, which you can find on the learning environment, so here, this one, I also already added the example exercises. So exercise 9 and exercise on database, you can actually already have a look at that, because I will already show you the example here, how you can connect with an online database. So first, the BIT04 database script. Maybe first explaining what this part of code is doing. I've showed you before that if you want to install a package, you have to do it like this. Install the package and then load the library, right? The next time you run this script, you go over this line, it will try to install it again. Now this might be a small package, but for some packages it can take like a couple of minutes before everything is installed, so you don't want to do that every time, of course. So this part of code actually takes care of that. It's just a trick that we use. I just ask for all the packages that are already installed, and then I will just check, is the DBI package that I need, is it already in the installed packages? It will just check. If it is not in the installed packages, then install it. Which means I already have it installed, so I can just run this code quite fast. It says, is the DBI in your packages? True, I already have it installed. So if I click on run, it will just skip. If you don't have it installed the first time, it will install. So this is really useful that you don't have to put it in comment or you forget. You write, oh no, and then you have to wait 3 minutes until you can actually do something. So this will actually help you with that. So anyhow, you will have to run this, of course, the first time. You will have to have the DBI package, because the DBI package is required to run the R MySQL, which you need to also contact or communicate with online databases. So similarly, I can check, do I have this package installed? And if not, please install the package. So I will run it. I already have it, so it can skip. And then I can immediately start loading the package. And then you see here, library loading required package DBI. So actually I don't have to do library DBI, because it will just check, you want to use the R MySQL package, then you also need to load the other one, and it will do that for you. So if I would want to skip this red line of code, I should actually first here add library DBI. But the code does that for you. So this is important for you to do in the R script, the database. Then the next lines of code from 23 is for a local database. So you can just skip it, and I won't ask that on the exam here. The only thing that is interesting in this code, also this here, MariaDB, you can have a look at it and read it. But it still causes some problems. So this will replace actually, will being phased out in favor of the new package. But if you want to use, you can still use the R MySQL for now. So I'll also skip that. And then this is what first I want to show you. So you will have to know how to communicate with an online database. So I will show that in the exercise. But it's also very useful, you don't need anything special for this, to have a local database, a very small one, which is called SQLite. And you can just save data in that and ask data. So this is just a small example how you can actually use that. Again, have a look if you have this package installed. So I have it already installed. So it will load here. And then this is actually how it works. So will be similar with the online database. You connect with the database, in this case a local database, an SQLite database. While with the online database you will have to provide host, where in the world is this database, and then of course the username and password. But this is for your local SQL database. Then you can ask for tables. So this is the connection, ask for the tables, and in this case you want the empty cars, and then you can list the fields in the database and read the table, for example. So here actually I'm using the empty cars data to store in this local database. And then if you want to use queries, queries are something like this: select data, the star means select all the columns from this table, and then this is where a certain field, the still from still in the field, equals 4. So you could do the same for the IRIS data set and create an IRIS table. Here, load the IRIS data in there, and then you could select all the rows, for example, from IRIS, where and then maybe sepal width is larger than something like that. This is how it works. And then of course, if you don't want to use it anymore, you close the database. The fetch is just if you want to get a record. Now let's show that how you can do that online. So now I move to exercise database R. So exercise 9.2, that's not for you because this is again on the local database. So you don't have to look for exercise 9.2, but start with 9.3. This is important. I will repeat again. So you can have a look and make exercise 9.1 on ggplot, but for the database part, not 9.2, but only actually 9.3. So let me show that here also. So not at 9.2, which is a local database, but only the online version here. And this is why I will now already show you how to do that, and then you can try that at home on your own. So how does this work? And it's actually quite nice things that you can do with that. We will actually connect. There are two ways here. I show you the difference here. Of course, you have to connect again by using the DB connect. The type of database is not SQLite in this case, but MySQL. And this is then the specifics for the online database. So this is where it is located. It is the Genome MySQL database at the University of California, Santa Cruz in the United States. Normally you can use the European version, but actually we used this today in the Python course, and the European version was online apparently. So we didn't have any connection, so we just switched to the American mirror site. So if you have a problem with one of these, you can use the other mirror site. So this is the American mirror site, European one. This is the port to use, so this is normally always the same, and this is also always the same, at least this here. So the username and the password is just a general, which allows you to read the data. This here is important, this is the database. What would this mean? HG19. Does this ring a bell? HG19, you also have HG38, you have MM10, you have MM9. What would that mean? Human genome. So the database is actually which genome you want to use. If you want more information on that, what you can do is just surf to the UCSC website. I don't know how familiar you are with the genome database. So here you can have a look at the genomes or go to the genome browser. The information that we'll ask now is directly from what we call the table browser. Let me just give a short introduction to the genome browser. This is actually how the genome browser looks like. So in this case, I'm working here with the human assembly of 2009, known as HG19. This is the previous version. The current assembly is actually the HG38 for UCSC. Or if you want to use the general name, it's this one, GRCH37, but actually 38 is the latest build of the human genome. this is maybe important to write that here. So if you were working with View, the latest version is HG38. Previous version is HG19. If you are working with mouse, then you use MM10, mus musculus 10. The previous version is then MM9, with the number of the assembly of the gene now. And then here, for example, I can just move, let's say, a gene BRCA1 as a classic one. And I see here, I click on it and I jump to the genome and the genome browser to the location. Go. And then I will find out where that gene is located. So it is located on chromosome 17. This is the position, 49 million, and so on. Also shown here. So on the long arm of chromosome 17. And then this is, of course, each block is an exon, and these are the introns, and it's pointing in that direction. And then these are all different transcripts. So this is now visualizing the data, but I can actually also download or query the data. So this makes it really powerful. You can do this in R, and then later on, actually next year I think, in September, probably one of the first courses will be the Python course, and we will do a similar thing. So what we'll do now is use this connection to connect with the database. Connect here with HG19. We ask for a list of all the tables that we can use. This is actually quite a long list of information you have available. So let me connect. And now I'll ask for a list of all the tables. So you see there are actually over 10,000 tables. And then how can you ever find the data you want, of course? What you could do is you could put them here, this list of the tables, assign them into HG19 tables. So that's the power of R, I would say. It will take a while to load. Now I have them, and now I can actually do a grep in R to look, for example, if I would want, let's say, ensemble or another specific type of table, I could do a grep on these to see which tables are available. Then I would see only 12. So I have an ensemble gene table, ensemble peptide table, and so on, shown here. There's an easier way to find this information, probably for you if you are not familiar with these online databases. What I would advise you to do is go here to the table browser. So you can also just Google for that. And this is quite nice. You select here the clade. So default, mammal, human, the latest, the previous assembly. I could also go to the latest assembly. So now we'll use this one. What do you want from information? Do you want information about genes? Do you want information about messenger RNAs, maybe on gene regulation, comparative genomics, SNPs? Then you go to the variation data and so on. So this is all the kind of information you could ask for. So all these 10,000 tables are actually in here, but this is easier for you, I think, to know which kind of information you want. So you go to the group, so in this case, for example, genes and gene predictions. And what do you want then? Do you want reference sequences or anything else from information? So let's stick to RefSec, and then this is the table. Do you want all of them? Only the curated? So this is curated, which means very reliable. So let's stick with all. And then actually to know how you use this in R, the trick is you use the describe table scheme. And this is actually where you will find the information for the connection with the database. This tells you the database to enter. So that is what you enter here, the database name. And then here I ask for the list of tables. If you already know the table, then you can specify. So in this case, the table is NCBI RefSec, for example. And then this is actually information I can ask the fields. So in this case, What is useful is the name. This is the transcript, NR and M underscore. I don't know if you're familiar with these transcripts of RefSec. Chromosome, it's located on chromosome 1. The strand, the start, the end, the start of the coding sequence, the end of the coding sequence. This one exists of counts 3 exons, and then each separate with a comma where the exon starts, where the exon ends. And this is also very useful, of course. Name 2 is actually the official gene symbol. So now, let's have a look here to find this information. So what I will do now is ask, for example, from a certain table here, select everything from the ends gene table. So if I would do that, I would get 200,000 records. For if you just want to test it, it's good to add limits and only give me the first 100. So it's not in the default script, but I'm telling you now, if you don't want to wait for a while until you have these 200,000 records, just add your limit 100 and you will only get the first 100 records. So maybe just show that to you, how then that works. You can just ignore these warnings. These are the column names, bin, CDS start, name 2. So you will see this is actually exactly the same as you find here. And then I ask for the dimensions and I have stored it here. 100 observations. This is actually the data from the genome graph. So in this case, I have the first 100 ensemble transcripts with their location on the chromosome, exon start information, and then here the gene name. So this is an ensemble identifier. If I would want to change it, I could switch to NCBI RefSec, and then I will get RefSec identifiers and these names. If I don't add the limit, this would mean I could just, within our script, get for an entire genome, all the genes, start positions, gene names, everything. So this makes it really powerful. And then you can search, filter, everything you want to do with that kind of data. And that could be something that I ask you to do. So have a look, it's not that difficult, I think, the code, how you can actually look for data online and fetch that data in R. And then of course, once you have the data here in a data frame, I think you can just use all of the rest you've learned so far in R. It's just making the connection with the database, selecting the correct database and the table. And once you have that, then you can work within your data frames. Okay, so the code, the exercise code is already online for 9.3, so you can already have a look and try that. Maybe then play, I showed it now for ensemble. Try it out at home for maybe another table. Look into the table browser and see if you can find another table, maybe other kinds of information, and try to play with that. Okay? Maybe difficult, or you're all very quiet? Or are you impressed with what you can do with it? Actually, one application could be sometimes if you would want, you get like a gene list of identifiers. How do you have to deal with this? You could just import it as a CSV in R and then look for the information with this. You could just try to look, can I find these identifiers in the human genome, in the mouse genome, and get any kind of information, even sequence information you can get. That's also possible. Okay, that's it for chapter 9. So I'm halfway for this evening, and then the other half is for the R Markdown and the Shiny app. So I'm still recording, and maybe I'll stop for half a minute. I think this will cover most of the species you're looking for, mouse, human, but you can also find frog, so Cynoplus, zebrafish, but also fruit fly, C. elegans, they're also in there. And maybe one thing now in between to mention. So I follow the course on a new tool we have, the Panopto recordings. So the screencast that I take now, I can actually, I don't have to upload it anymore to YouTube. I can just upload it into our learning environment, into Panopto, which actually is nice. So I think you can also see this in your menu on your learning environment. Already started. That I can actually add the structure or when something starts. For example, you want to know something about statistical testing 2. Where is it? You have to look for or scroll here in the 2 hour. I think it takes 2 hours. You can just click here, statistical testing 2, and you will immediately jump in the movie to that position. So that I think on the open book part of the exam, it can help to maybe quickly, yeah. Dan, indeed, you will have to have your earplugs or your oortjes, zoals dat we zeggen. Maar ik ga ervan uit dat je allemaal gaat kennen op het examen.
Dus je wel op het examen van de les nog
And the people at home, they can just put it on. They have to put, because then of course I don't know if you're just speaking, and could also be possible, of course. If you are using these, I will check what you are doing, of course. Okay. So in this chapter I mentioned introduction, statistical testing part 1, 2, and also if you want to hear again what I told last time about the project assignment, you can jump here and then you will immediately get to the part where I talked about the assignments. Okay. And then the next part, which is quite important because you can use this for your assignments. Maybe first show you what it can do. So I opened here the example first R Markdown. So you see no longer a .r file but a .rmd file. I can create that here, file new, and then switch here to R Markdown instead of a normal R script. And you might already have noticed that you can make also a shiny web app in this way. That's for later this evening. Then you get like a template like this, and then you can add chunks of code. So what is the difference? You have here parts that are not actual codes, but what we call markup. And this is where the actual code is, and these what we call backticks. So you maybe have to look where it is on your keyboard. So you use 3 backticks, or you can just copy paste it. And this is actually where the code is. And you might have noticed then you have a play button. So you could each time execute this part of the code. So it means this is code. I'll tell you in a minute what this means. You can have code here, and you can already see this is just normal R code. So if you already worked on your project, you can use this as a template and you just copy paste your code from the R script, paste it between these backticks, and then you can just add some documentation actually here. Okay? What is then nice is that you can just click here knit to PDF, and it will just create the report for me. And this is then what you also have to upload. So you see here I have my introduction, who I am, when I created this file, my R Markdown, and it can actually also not only show the markup, you can show the code, but you can also show the output of the code. And in this way I actually have a full report. This is actually very useful if in the lab you want to make data be analyzed in an automatic way. You could prepare an R script, and anyone which has the R Studio could just say, this file, generate a report, You run the script and you get a PDF as output, which is very nice, of course. You can also add these plots, anything you know, everything you know from R, you can just generate a report using R Markdown. So this is really powerful. And what is the most difficult part here is to get, for example, I think the HTML will easily work. Maybe you have to install 1 or 2 extra packages, but probably every one of you will get errors when you start to knit to PDF. What will those be? So I will already tell you how you can solve them. How these PDFs are being generated is something we call LaTeX. Written LaTeX. And probably you need to install some packages to get it up and running. So in most cases, errors that you will get is something like this. LaTeX error file frame.sty not found. Or you could get something like titling.sti not found. Then you just need to install those packages. Sudo direct install, that you already know from the Linux course. Text live -framed for this one. If you would get the titling, text live.titling. What you will have to install anyhow is the install text live, that's the default. So probably these 3, and then you will probably still get an error. Within R, then the trick is to also install tiny text. So then the last step is here, packages install tiny text. I already have it installed. And then you can also install the tiny text. Normally, for most of you think this will allow you to run also the knit to generate the PDF which you need to upload. If you have another kind of error message, just copy paste the error message and send it to me, and then if you can't find online help, I will try to see what you need to install. It's just probably because you have a missing package either within your Linux system or within your R environment. In most cases, what I also have to do is just Google the message, and then often you see, oh, you need to install that package. But this is probably what you have to do anyway, so it's good that I can already tell you before you start using it to install these. Okay? And now let's give me the explanation of how you should use it. So first, maybe general, what is the R Markdown workflow? You have not an R script, but a .rnd file. It is actually a report, a plot, which contains embedded R code between these backticks, and also Markdown codes. So this is then you need to know the specific Markdown syntax. I actually have an R Markdown cheat sheet also in the supplementary information on the learning environment. Okay, so you can also use that one. And then actually what you do is you generate your report by using the render or the knit, and then you can choose, do you want HTML, even Word, or PDF. HTML normally will work anyway, but for the PDF or the Word you might need to install some extra packages as I explained to you before. So this is how it works. If I'm talking about knitting the file, it's actually just converting it, adding codes, maybe even results, producing the plots, and then write it to either HTML format or to PDF format. So that is knitting the file. And it's actually just a conversion. It uses standard to convert it, for example, to HTML, to PDF, or to Word. If you want to start a new one, you go to File or Markdown, and then you can install a new one. Or for now, what you can just do is use my example, first RMD, open that one in your RStudio, and then you can also start maybe modifying, save it as another file, and use that as a template, let's say. That's also useful, I think. So the first time you want to use the RMD, R will probably ask you to install some additional packages like these here. So then you will have to click yes, and then probably wait a couple of minutes until all of these packages are installed. Yes, so So that's another way. If you click the first time and you do it from the file new, you will get these screens. This is just some screenshots to show you what you have to select. And then there are different options: document, presentation, template, shiny, different ways. So this is actually the default, the HTML. And then later on you can still choose. So the example I have is actually document HTML. I gave it a title and added my name, author name, and then automatically you will get this what we call a YAML header. So this is already some kind of markup showing you actually a key and then a value, a title. This matches this here. Author matches also here. The date of today, of course, in this case. And then the output is what you chose as a default, HTML. So which means if I would knit, it will generate an HTML document. If I would something else, I could choose PDF and then the default would be PDF. But I already showed you that it's very easy. If you want to change it, you just click here and you can easily choose. You can even choose with parameters. What does this mean? You could select a file. So if someone in the lab who wrote this R Markdown script to generate reports in your lab, someone in the lab could just have RStudio installed on the computer with your script ready. He or she just has to knit with parameters, click where the file is, the CSV file or Excel file, on the computer, and then it will automatically generate the report. So now back to the presentation. So this is more information about this YAML header that I discussed. And this is the Markdown. So what can you choose? This is how you write it, and this is how it will look like after you've knitted the file. So these are just with the hashtag, the headers. The more hashtags, the different or the lower the header. So this is like you use it in Word, for example. You have different kinds of titles, and this is the same. The more hashtags, then the smaller actually the font. If you would want italics or bold, you use the stars, superscript strike through, and so on. And then you see here what happens. So that's the Markdown. So more Markdown, you can even add tables. Well, of course, you can also use the structure, for example, to generate these kind of tables. And so the Markdown is actually, if we go back to here, then this is the R Markdown. So where you don't have the play button, this is code. It also has a light gray background. This is the R Markdown, which means next block of code here, again, Markdown. So these mean two hashtags, which means I will have a title of heading 2. Again, title, heading 2, including plots, and so on. So this is actually what you see if I knit here. Structure of the IRIS dataset, including plots. These are these titles with a certain heading then. Similarly, if I knit to HTML, then it's a bit different. Structure, including plots, and so on. So that's for the R Markdown. This is good actually to add some comments on documentation, of course. And then the code. So first thing you do is use ordinary R code, like you've done the past weeks. If you already use it for your project, just copy paste the R code and start from there. And then one thing that is important is these options. So these options you actually added at the first line between the curly brackets. So after the 3 backticks, you can actually add options. What is important is these options: eValue, evaluate, and echo. So you already see here whether you also want the code to show in your result, in your report, and if you also want to display the code along with the results. So you can choose only to show the plots and the Markdown without the code, without the outputs, or you could use one of both or both. Of course, for the report that you have to upload, I want to see everything. So I want to see and the code and the output. So that's important to keep in mind. So in this case, I think I have it here, yes. So what you do is you include true, also the echo to true, so which means I will also see your code in the output file, and I will also see the results, everything actually. If you would want to hide it, probably maybe in the lab. If you want to generate a report in the lab, you don't want your colleagues to have a look at the code, because they probably won't understand the code, so then of course you hide the code for them. But for me, I also want to see how you did it, because that is part of the evaluation, of course. So for me, you will have to show it. And then this is important, this is the general. So for actually all, if you don't want to add it each time in each block, you could set it here in the general knitter options. So if you would set it here, it will take those values for the rest if you don't specify it here. So you don't have to either you copy paste it each time, or you set it at the top in the option chunks. So here these are the global options that we set. Maybe one thing that's also interesting for your figures, what students during the daytime had a problem with is for the size of the figure. If you're knitting a report, sometimes your figure size, it automatically adjusts. If you want to predefine your width and height, you can also do that here. You can just look it up on the documentation or online. You can set your figure width and height also in here. Which means if you knit it, I will also see if I would rerun the code, it will have, let's say, 10 centimeters or 5 centimeters, something like that. So you can also specify that here. And then what you could do is, while you're developing your code, you can actually also not run the entire document, knit it, but also run only a chunk of code. So I could just play here, and then you see I will have my code and I have the output here. So which normally, if you would use a normal R script, you would get the output there. But here, now I can see it here. I could just go to the next part of code, the structure, I click on the play button, and I see the outputs. The plots here, so I'll have it twice, without or outside the loop, and then here in the loop construction, I click on the play button, and then this is why I got error. You see, figure margins, in this case, where is it here, too large. So I could set it there. So that is why I just can't apparently show it here. So then I would have to provide more space like that, but I could also just specify it here. But of course, if I will knit it now, normally it will work. Let me show that. So here you will of course see nipples. So twice because outside the loop or without loop and then inside the loop. So this might be a good template for you to start and then copy paste your normal R code and save it as another RMD file. So I hope this is more clear now, how you have to use the markdown to produce your report and to upload it. This counts for 25% report on your own dataset. So I think quite important. Also, there is no option to redo this. So there is hint revisit. So you can't repeat this. This is an assignment. You provide me with the report on time, and then the 75% on the exam, that if you do not pass, you can do it again, but you can't do that again. That's also in the ACTF fish. So there you can find that. So it's important to know. If people wait and they provide me with nothing, if you just try some visualization techniques, normally it will be okay. It's to force you to practice before you come to the exam. It's really important. Okay? It will help you prepare for the exam. That's actually why we do these assignments. This is if you would want to add a parameter with a file name. And then this you could add here, I told you about the nitwit parameters, and then it will ask you for the file name. So for someone in the lab, then it would be easy also to run this script. So that's, I think, everything that I wanted to tell you about the R Markdown. And then the last part is the Shiny app. If you would really want to do it, you could also make a Shiny app and use that for your project assignment. But I also told the students in daytime I would not advise it because this is even a higher level. And maybe for in the future you can have a look at this, but not for the next 2 weeks, I think. You don't have enough time to have a look at this. But anyhow, I want to tell you what is possible. Also on the exam, I won't ask you to write me a Shiny app. It's also good to know. Unless, yeah, I want lots of students to fail, so that's of course not the purpose. So no Shiny app on the exam, but I hope I can convince you that it's very nice what you can do with a Shiny app. So the report in the R Markdown is just static. You run the report and you can print it, give it to a colleague, share it, whatsoever. With the Shiny app, anyone who you share it with can actually play with the data. That's why it is so nice and why it is often used. So maybe first show you a demonstration. So you could just from the learning environment download this one. This is a small example. Shiny, it's also an R&D file. What is different now, you see here, runtime, Shiny. And now I don't have a knit button, I have a run document button. If I now click and also execute what is shown here, again, normally R code, but actually you see I have some options. I allow the user to select the input variable here in this case, and also here to specify how many iris flower, how many rows do you want to show. The default is 5. This will be the input, and then I will render a table and show that. If I run it like this, I have a really nice app here. Shows 5 lines. I want 10. It automatically updates. This is what an app is all about. So I think this is very nice if you can make it. It's not that difficult. It's just, again, learning a bit the syntax, how to do it. So here the histograms, these are static again, but this is very nice, I think. So maybe first show the code again. Histogram with selection of a variable. So again, the select input. It will be the variable, the label, and these are the choices. So this is important because this, of course, matches the columns in your data frame. So these were in the iris data set of 4 columns. So the user will be able to show one of these 4, and the plot will actually change. So I will render a plot in this case. This is important. Numeric input here. Select input is just text with drop-down list in this case. Here I render a table, while here I render a plot. You can then do the same, and you can also make a bar plot, and other kind of plots. So in this case, I will actually use this var the input and use that here, the iris data frame, and use the var column. So if I change here in my drop-down list to one of these, it will actually update my histogram. So in this case, I could just say this is the histogram of the sepal length, show me of the sepal width, and it automatically updates. Petal length, petal width. It runs really fast. So this is how you can use an app. You can even publish it online if you want. There's a shiny.io website where you can also publish. Either free, which means it's accessible to anyone, or of course, with an account, you can have your own Shiny server there, use the Shiny server, and actually publish your apps there and then share it with some colleagues or something like that. And now, a bit of more explanation. This was, let's say, the live demonstration. So what is Shiny? It is to build an R package to build interactive apps. So again, of course, you will have to install the package. You can use it in combination and then with RMD, Markdown, or you can also use it as a standalone app. There is a small difference. The standalone app is even a bit more difficult to program. What is the difference? Here, the Shiny app is the one example I showed you, which means it is embedded within the Markdown. The other option is a standalone app. I will show you a piece of the code how you can do that, but it is even more difficult. It is then in combination also with cascading style sheets and JavaScript, and the code is even a bit more different, more like you saw, I think, in web technologies then. So what does is the Shiny app or the package? It just turns, so you saw a runtime, then a Shiny. It will exactly run it as you do for R Markdown. What is the difference is that you have interactivity for your user. So anyone can play with the data, change using drop-down list, but you also have sliders, lots of options that you can choose for the user to actually play with the data. And then this is just how you can start a new one within RStudio. If it's the R Markdown version you want to use, you go to File, R Markdown, and then again you type Author, Shiny Document. So this is like I did, where you have here then the runtime, is then an RMD, and you have it like this. It opens on your computer in the browser, and I showed you a demonstration. The other option is then File, not R Markdown, but Shiny Web Application. And then you will see you will get another screen where you will develop an app.r as a single file on a certain location. And this is actually how it looks like. And this is, I think, a bit more advanced. So maybe if you have time later, not the coming 2 weeks, you can have a look at this, but certainly not for now, I think. Right? But I hope I've convinced you what you can do with this, and it's very nice. Apps you can develop by playing with your own data. So you see here then you use, of course, the Shiny library, and then here you have to actually develop the user application. Here then the server, and then you see that the code is quite different from normal R code, probably makes you think a bit more on web technologies. So I have also an example on the learning environment. If you just want to have a look, get you started, feel free to try it out. But not to know, or I will not ask this on the exam. For example, here then you can ask the number of bins with a slider, and it will automatically then update your histogram bins in this case. And if you want more Shiny RStudio, there's a tutorial with also movies actually how you can do this. And that's it for the course. I don't know if you have any questions for me, maybe on the project or on the exam. Or do you want me maybe to go over the example exam? It's maybe good to show you what I will ask. Any other questions for now? Yes?
The report,
The report?
still don't get it. Like, should you just make plots or should it make sense with the data you use? Like,
Okay. Yeah.
So
maybe I'll start from my example to tell you what you should do with the report.
it's not that difficult to make plots, but
No,
yeah.
certainly not. What I expect you to do is, first of all, in our Markdown, you chose a certain data set. So the first part in our Markdown will be an introduction. What is the data set about? Which variables? Numerical, nominal, what did they measure? A bit of background information, because it's a report, right? So that is here in your R Markdown. Maybe a link to the data set is also possible. Also important, of course I will have to know which data set it is. So either if it's your own data set, you will have to send it by email, because I need to load it. If you're using it from online, you can actually use, in the beginning of the course we saw you can read directly from an URL. So it would help me, if I have to correct it, to load it from the URL, the CSV directly, because then I can immediately run, execute it, and it will work. In the other case, I will first have to download the CSV files, load it on the position on my computer, you know, so if I have to do that for 30 students, it helps if I can immediately have it loaded from online. So that would be a big help for me. So a small introduction on the data set, but you could immediately already start with like a summary. So you show first of all the code, and then you show the details. This will already tell me which kind of variables you have. Could not be the summary, but you also have description. We saw several options, maybe even a new package. That's possible. So actually an introduction that I know more about the experiment and I know more about the data and the variables. So that's actually already the first part. And then what you do is you use visualization techniques. If it are numerical variables, which techniques can you use? If it are nominal ones, you will use other visualization techniques. And of course not the default. You will of course get marks for that, but if you use the R color blue for the coloring, maybe you add a legend, you specify the labels, you modify the title, maybe the x-axis, the y-axis, things like that. And you show me that you go beyond the basics, because that will give you a higher mark. If you just use the basic graphics, you will probably pass, I think, if you have a lot of code and stuff like that, and you generate a report, and they will pass. But if you add more colors and you improve the quality of the figures, then you will get a much higher mark. Somebody already asked me this evening, how many tests do I have to provide? If the rest of your visualization is impressive, if you would, for example, have lots of variables, you use dimensionality reduction, that's also very good for me. If you would use multi-dimensional scaling of TSNE instead of a test, that's also okay for me. If you want to provide a test, one is sufficient also. Okay? So it don't all have to be statistical tests and interpretation, no. It's also about visualization, working with the data, filtering the data could also be a part, the first part for example. Maybe you will not use all of the data. So if you can show me which, you sort the data, you filter, maybe you do substitutions. If you would have an MF, you replace it with a female, or maybe something else of a variable. That it's more human readable, that's also good to put inside. And of course, what is also important, what I will use for the marking, is documentation. If somebody else wants to read your code, that he understands your code, also for me. So I often use, I think in my scripts here, lots of explanation to help you, then I also expect you to do the same for me. Okay? It will actually also help yourself if you do that. If you write a script and a year later you have to look again, probably, how did I do this again, if you didn't write any line of comment. So it will also help yourself. Yes. And that's it more or less. Yeah. And then some figures. Also, of course, if you use a for loop, maybe a new package. You just Google what certain visualization, maybe a new package that you use. It's also very nice. Another type of visualization. So don't only use, I use the parallel techniques, the violin plots, but there are other kinds of visualization. So then you show me you can install a new package. You show me that you can read the documentation on how to use the new package. So that will also get you a much higher mark. Is that more clear now what I expect you to do? So an introduction, document your codes, show me both codes and output and figures in the R Markdown. That's more or less it. So a statistical test is nice, but not required. If you replace that with a new package or multidimensional scaling or something like that, that's also fine. But you need at least, I think, 4 or 5 different parts in your code. And you might have noticed I didn't do any special things, and I already have 66 lines of code. So this is the line count. So we will not only count this, also, of course, don't write 100 lines of markdown and text, right? Should be in balance. And then if it exceeds the 150, then that's okay. But also, for example, these lines count as lines. Any other questions? No? Then maybe let me show you the exam of last time. That's online to show you what I expect. Modules, and then the supplemental information. So here is also the R Markdown cheat sheet, also for ggplot, and then for the statistics. And then this is actually the example. So you already see here, I think now the project counts for 20 points, so it's always 25% for the project, 75% for the rest of the exam. So then, normally from each chapter I will ask something. So I always tend to ask questions about all the chapters, not only from one or two chapters, so that I know that you have a look at all the chapters, because some students don't get as far as the last chapter. You should read and work with the entire course, of course. So these are not that difficult, I think. It starts with some basic questions, give the data type of class data. I always give you some example codes, so hopefully you know what true false is. So I could ask that for other types. Then certain conversion rate is character, as character. What does that mean? What will happen? Then you give me the outputs. Or I give you a piece of example code and I ask you to explain what is the difference in this case. So I could give you something else. Maybe a data frame, small data frame. If I would run this line of code, what will happen? Would also be. So these are then some examples. Then here about the statistics, interquartile range, quantiles. You can explain in your own words. The questions will always be in English, but you can also answer in Dutch. That's also okay. It's no problem to answer in Dutch. And then on the base graphics, for example, what is the difference between text and m-text? So in the margin, the M stands for the margin. In this case, AB lines. So if you want to add extra lines, what does this mean? HV, horizontal, vertical. Horizontal, vertical. Here, what happens with par 2 by 1? If you want to make a combined plot, then what is the my? It's like the mar for the margins, but the my is then. This is not in inches, yes. And then just explain what you can do with the scatter plot. Which kind of data do you use? Visualization. Explain what the regression line is, how you can add it to a scatter plot. Explain how the parallel coordinates work. So you have this vertical axis, what exactly is happening, how you connect them, how you plot that, so that you know how it works. And then here, explain briefly what p-value z-score means and explain the Tuckey-Kramer test. So for the tests, you can use the cheat sheet on the exam. Okay. And then about ggplot, makes use of aesthetic mapping. What does that mean? So I think 2-3 lines, what is on that one slide. Explain what this faceting technique is, for example. So I've discussed this evening, what it does. So I could ask the same about the GG repel, for example. And this is actually the closed part. So it will also be the same as for the other exams. In the lockdown browser, the first part, and the second part is open book. And then the second one is just some questions, exercises on a certain data set, what you will have to do. So you have specific questions, clearly also marked how I score, what should be on it. And then also I'll give you how it should look like. That will help you a bit, what I expect. Okay, so in this case they had to make a plot like this, and then a plot like this. The tricky thing is, in most cases, that you have to change certain settings. For example, I think in daytime I asked not a normal bar plot, but a horizontal bar plot, I think. And then you also had to add the labels. So for example, if you would have a bar plot, I didn't ask that here, to put the labels on top. It's possible. You look in the help how to do it, or with the position. You actually know where to position it. So that's all the extras. So you get already quite some points for this, but then in the details, maybe to change specifically the legend or to add a special feature, that is to get all the points for the question actually. But I think if you practice, you have the example code that you can use. I hope that it's not that difficult for you. Okay? Or does this look very difficult for you? I'll know it too. Sorry?
When I do the exercises, I try some stuff and it kind of looks the same, but then I look at the exercise you uploaded, and sometimes it's different.
Yeah, that's also important to tell.
My thing is kind of unlogical. I can see it. Sometimes I do unlogical things, but
there are always different ways of getting to the same solution.
But if it works, it's
yes,
fine. Or
and you give me the same results, but your code is a bit different, you will also get very good points. No, very good mark. That's not a problem. Yeah. It's just two things. The lines of code must be more or less the same. So if I write it in 10 lines of code, you write it in 100 lines of code, you might get 1 or 2 points lower because of that. If it's much slower, that's also important. But for these kind of exercises, normally that will be similar. I don't expect you to have much more lines of code, or that it works much slower. So that shouldn't be a problem. So yeah, if I look at the exam of other students, if you would compare all of them, you would have probably 5 different solutions getting to the same answer. So that's not a problem. Yeah. It's the result that counts. And if you don't have specific details, then I look into your code, how you used it or what you missed, and then you can clearly see if, for example, you would not be able to remove the outliers, then you would lose half a point. If you're not able to write it in a for loop, but use it in 4 lines of code, no, it was 6 lines. So let's say what you can do, you can actually put this in a for loop. So it's that too difficult for you, then just write it in 6 times the same, you copy paste, and then you will lose, in this case, you will lose 1 point.
You should not give both. And you should.
No, you choose. Or you can already start without a for loop, and then once you have the for loop, just put the other lines in comments. That's also okay for me. But if the for loop doesn't work, then please give me the other part, right? Because then I can already score you for that. Because if you have a for loop that's not working, yeah, then it's better to have the rest, to get marks for the rest, because if it's on 3.5, that you will get 2.5 points, and you already have more than half for this question. Other questions? No? Okay. I think then we can stop for today. If you have questions on your report, of course you can still email me. If you have a problem or a question, don't hesitate to email. And also for the people at home, I know if everyone here already, I think maybe some did not send an email for the dataset, so don't forget to do that. Okay? And also, I think only, let's say, half of the students, or a bit more than half of the students, send me an email or a message about the dataset. Don't wait too long to start. And don't forget to upload it the day before the exam. Again, yeah, important. Broadcast interrupted. Dus ik ga deze ook weer online zetten en die kan opdoen. Moest er een probleem zijn met de opname? Die in elk geval lukt. Ja. Dan hopelijk zie ik een beetje zitten op het examen.
Ik vind deze lastig stand dat is niet verder vakken in deze.
Het lastigste.
Ja, maar ik ben ook super slecht in statistiek, dus voor mij is zo ziet het wel dan eigenlijk.
Er gaan maximum 1, misschien 2 vragen over statistiek, dat is het. Je hebt gezien, in de training is zoveel statistiek aan het toepassen.
Als ik er niet veel naar op, dan moet ik niet weten hoe dat ik mee verder moet, of ik dat niet...
Bedoel je over de statistiek of over de rest?
In het begin, want uiteindelijk gewoon één opnieuw van de PowerPoint 1. En dan, ik moet alles zitten Google, alles zo, wat is of hoe doe ik, how to.
Maar je hebt toch al de voorbeeldcode, de oefeningen staan online, altijd daarvan vertrekken, op het examen ook. Dat is echt belangrijk.
Voorbeeldcode, maar dan heb ik een oefening en dan markeer ik iets dat ik niet weet en dan zie ik de oplossing en dan denk ik, maar moet ik dat weten? Door de Google, is dat de bedoeling?
Heb je al veel de help gebruikt in een studio?
Ik probeer dat, maar ik vind dat heel vaak niet of verstaan. Ik heb in de uitleg niet uitgelegd. Ja, dus dan moet ik dat alsnog googlen.
Ja.
Op
het open boek mag je dat ook doen. Hè. Dus, ja. Normaal, de open boekdeel gaan gelijkaardige oefeningen zijn dat je gedaan hebt. Je hebt dat nu ook gezien. Hè. Het was een barcode en een boxplot, dus misschien gaat er een ander type visualisatie zijn dat je gaat moeten doen. Vertrek van de voorbeeldcode. Hetzelfde stukje voorbeeldcode of van de oefeningen, kopieert dat. Zorg dat, voer het nog een keer uit, wat dat al werkt. Dan is het gewoon dataset correct inladen, dezelfde data, en blijf er even afkijken wat dat al werkt. En dan is het gewoon aanpassen, een kleurtje of een tekst of een labeltje of de assen of zo. Ja, en dat is het.
Soms niet verstaan wat ik aan het doen ben. Dan denk ik zo, ja, ik kan dat kopiëren, maar hierna kan dat niet meer werken. Ik kan dat niet zelf. Ik heb niet het gevoel dat ik daar iets mee kan doen. Ik heb hem al niet voor gehad mee. Bij sommige dingen doe ik wel een helft van.
Ja, maar nu weet ik met die databank bijvoorbeeld. Als je een bepaalde soort data nodig hebt, die informatie die je er al van kan uithalen, dat is een ongelooflijke bron.
Jij bent er gewoon te weinig.
Ik moest toen maar werken, statistiek, dat ik nog niet, maar mijn collega die instelde was geen formules, ik verstelde niet, want die vertellen dat over, maar dus ik heb heel spel goed formules gezocht, dat lukt mij dan wel. En dan snap ik wel ik kan me dat dan voorstellen, moest er daar in zoiets steken dat je dan andere dingen mee kunt doen. Hè. Maar dan snap ik dat. Weten we weer een nieuwe soort start. Het is zomaar wat aan het doen.
Dus het weer toepassen iets.
Ja, maar ik heb het met alle vakken niet al. Het is altijd zo.
Wat zijn wij met de
handig kan zijn, maar ik sta er niet aan.
Misschien is dat, ja, waar je nu werkt, dat ja, inderdaad, is het in een klinisch labo of in een bepaald ander type labo dat je zit?
Klinisch labo.
Ja, het hangt er een beetje vanaf. En welk soort data moet je daarmee aan de slag gaan? Heb je data in het labo dat jullie gebruiken? Of is het gewoon ja, tegenwoordig allemaal technologie, toestel, staal? En je krijgt een rapport eruit, is dat de, of?
Ja, nu voor onze flow, maar ja, dan hebben de mensen met die ons gaan samen met de mensen van alles. Hebben ze wel zo voor het aflezen van de flow wel dingen gedaan, maar dat je allemaal dingen mee. Ja, voor de rest, ja, is het veel.
Ja, voor te studeren, je hebt bepaalde data. Je maakt eigenlijk twee soorten variabelen. Het is iets dat gemeten is, of het is iets dat je een labeltje kan opplakken. Dat bepaalt dan wat je ermee kan doen.
Ja.
Als het iets gemeten is, dan kun je er bijvoorbeeld een histogram mee maken. Is het iets met een labeltje, ja, dan ga je een ander type voorstelling. En dat is juist het belangrijkste dat je weet van wanneer kan ik een boxplot gebruiken, wanneer kan ik een waarplot gebruiken. En dan kijk je naar artikels of online. Het zijn altijd hetzelfde type, een scatterplot of een barplot. Het is altijd hetzelfde. Het is gewoon een kwestie van de juiste kolom, die dataframes, dat is belangrijk. Dat je zorgt, rijen en kolommen. En dan je dan zegt van, ik wil nu die kolom gebruiken. Dat is,
Is dat ook wat we bedoelden daar straks ook met? Ja, je kunt 1000 plots maken op zich, is dat niet zo moeilijk, denk ik. Maar, je moet toch... Ja, maar dat is misschien hoe je zo weer over nadenkt. Dan denk ik, ja, heeft dat zin van een plot te maken van dat en dat? Ik bedoel,
ja,
voor
nu maakt dat niet meer uit van wat jij bijvoorbeeld.
Ja, maar dat
als
is bij mij niet
zelf
als dat niet logisch is, waarom ik dat doe, ik vind dat, dat gaat bij mij echt niet in mijn hoofd. Ik vind dat super moeilijk. Om dat gewoon te doen, omdat je dat moet doen en niet omdat je zegt, ah ja, maar ja, je weet hoeveel patiënten tussen hier heeft het en hier heeft het reageren op die behandeling. Kijken of er een verband ligt tussen. Dat is logisch dat ik daar in het plot ga zeggen. Maar nu snap ik dat ik zo snap ik aan doen. En dan,
dat is niet verhaal wat dat
ja.
Dus nog iedere keer aan een voorbeeld dataset, maar dat is een bepaald experiment. Dus ook je dataset dat je nu gaat gebruiken. Ze hebben toch een bepaald experiment gedaan. En...
waar dacht je wel in mee? Ja. Maar ja, ik vind met die iris-dingen en al, doe ik dat, maar ik weet eigenlijk niet wat ik kan vergelijken.
Dat is eigenlijk data gewoon te spelen in die iris-set. Je hebt gewoon gemeten, die twee typen bloemblaadjes dat je meet. Je hebt 3 organismen en in feite is er een verschil tussen die 3 en dat je inderdaad ziet van als die blaadjes in die soort is allemaal groter, terwijl bij andere species zijn ze juist allemaal kleiner. Dat is in feite wat je in die data ziet. Dus dat kan hetzelfde zijn, bijvoorbeeld, je hebt een bepaald experiment in het labo. Een controle, je doet 100 metingen, je doet een bepaalde behandeling of iets, met datzelfde stel ook 100 metingen. Je meet iets, wat doe je? Je moet een boxplot. Je gaat zien, is het zo je boxplot? Ja, er is eigenlijk geen verschil. Is het zo? Ja, er is wel een verschil. Als je zo daarop een statistische test doet, dat gaat niet significant zijn. Als je daarop een statistische test doet, gaat het wel significant zijn. Eigenlijk zie je dat aan je boxplot. Zo moet je in feite proberen.
Dus ja, ik zei het is gewoon dat je dat denkding niet hebt op die manier. Allee, ja. Het zal wel komen. Ik ben er zeker.
Ik wel een andere met je hoofd.
Ja, ik heb
heel abstract allemaal.
ik
Het
zie
is
het
maar
labo,
maar
verschillende mensen, verschillende denkwijzen. De ene denkt heel logisch, de andere denkt heel...
Maar dat logisch denken, dat is heel moeilijk voor dat aan te leren, zeg maar.
Ja,
Ja.
ik vind dat echt moeilijk. Allee, maar ik vind dat heel erg van een
De bedoeling van hier is in feite, als je een nieuw soort data krijgt, dat je weet wat je er allemaal mee kan doen.
Ja.
Dus het eerste wat je doet is, je kijkt welke data zijn het zaken die gemeten zijn, of zijn het bepaalde categorieën. Dan kijk je zo één dia van, ja, zijn het gemeten, dan kan je dat en dat doen. Kies programma, boxplot. Is het iets anders, ja, dan is het een barplot, of frequenties dat je berekent, of heb je er meerdere, dan kun je bijvoorbeeld, zijn het 2 gemeten variabelen, dan kun je dan een scatterplot. Stel dat je er 3 wil vergelijken, dan kun je bijvoorbeeld die bubble chart of die parallel coordinates. En er nog veel meer, dan kun je bijvoorbeeld dimensionaliteitsreductie en dan in 2 voorstellen. Zo moet je in feite denken in die termen. Welke data is het? Wat ga je ermee doen?
Ja, ik denk dat ik dat ook altijd veel te veel ineens denk. Ik heb dat met anderen ook altijd dat meer stukken moest overleggen en zo. Dat begin je dat. Ik wil over alles tegelijk nadenken en dan zit ik er gewoon door de bossen. En nogthans, dat helpt mij wel van dan te studeren, van zo anders na te denken over dingen. Want ik ben wel al op het werk. We hebben zo, we moeten hemovigilantie overnemen bij ons, als we een collega in zwangerschapsverlof hebben. En ja, er wordt daar veel statistiek op gedaan, hoe weet wat er buiten gaat binnen gaat, qua verspilling, welke bloedgroepen, alles ja, van de NIAS-normen, de vragen, dat allemaal met keihard statistiek en toestanden te doen. En je kunt dat wel ook zo wat mee te denken, omdat ik dat nu aan het leren ben, maar soms met die theoretische voorbeelden vind ik dat moeilijk. Daar denk je zo mee.
Daarvoor moet je dan dat tabelletje pakken. Hè.
Ja.
Heb ik 2 nominale, heb ik gemeten, hoeveel heb ik er, en dan zie je in feite van, dan kan ik die test doen. Met dat kan ik dat doen.
Ja.
Vergelijk dan ook, probeer dan te snappen met de voorbeeld. Ik heb iedere keer proberen een biologische dataset. Ja. En op basis daarvan, en voor de rest is, hoe meer je doet, ja, dat is een beetje het probleem hier, dat, ja, op 6 weken tijd, en die contacturen, je moet er soms veel tijd in investeren. Hè. Dat is een beetje...
Ja, ik ga, na mijn werk ga ik nog naar de BIP. Terwijl van 5 tot 10 uur in de BIP is, zeg maar, je bent snel veel uur gepasseerd.
Ik heb al 3 weken niets kunnen doen, omdat ik gewoon 12 uur op een dag aan mijn werk zit. En dan blijft er gewoon geen tijd meer over. En dan in het weekend lig ik gewoon te slapen, want ik ben gewoon moe van het werk. Maar het is nu tijdelijk, hè, maar...
dat is het grootste probleem met afstandsonderwijs, waardoor er zoveel afvallende combinatie gewoon dat enorm moeilijk is.
Maar nu, ja,
mijn voorstel is geen 4/5, maar fulltime, het is toch alleen. En het is gewoon iets waar het is eigenlijk waar je zegt, je moet oefenen. Dat is niet, ik ga met een cursus pakken, ik ga wat lezen en dat oefenen ik wel echt heel veel tijd. En ik vind dat wel tof, ik vind dat leuker dan om te leren, maar ik heb elke keer het gevoel dat ik te weinig tijd heb. En ik heb gezien dat we van een week les hebben ook.
ja, dat is helemaal weer.
Ja, en dat vind ik...
En dat is waarschijnlijk data van.
Ik wil dat niet missen, maar
Je verliest dan wel weer
vorige keer voor dat voorexamen hadden we dat ook, de week ervoor, al de rest van het volgende vak. Ik heb daar niks zitten doen, want ik kan niet opletten, ik ben met mijn kop bij dat ander.
Ja. Maar je wilt die les ook niet missen, want meestal zijn ze ook nog een keer belangrijke dingen zo over.
Ja, u kunt wel de opname dan
Ja.
later online bekijken, hè. Of via de livestream, of bij de screencast bijvoorbeeld.
Ik weet het.
Of, want we zien wel, het zijn meestal 5, 6 mensen, maar dan zijn er voor 10 wel die van thuis mee volgen.
Dat is weer.
Dat is waar, ja. Als je dan kijkt, ja, dat is waar. Dan zie je wel bijvoorbeeld, we kunnen ook de recording zien, dat er sommige mensen dat wel nog later ook bekijken.
Ik heb gekeken aan mezelf. Ik ben niet van contact op.
Ik weet niet wie, maar wel het aantal views. Ja.
Maar ik ben hier geraakt omdat ik nog zo'n keer inpikken als je
Ja, ik zou ook altijd langskomen, maar ik kan ook wel, er zijn andere mensen die zo qua afstand niet gaan komen van Limburg of van Nederland en je komen. Maar anderzijds is het wel denk ik interessant voor toch. Ja.
Ik ga nog zien wat ik ga doen.
Ik ga waarschijnlijk komen, ook al zit ik zo beter te denken. Ja.
Dus een avond studeren dat je kwijt zijn in de week voor je examen. Ik vind dat niet ideaal. Dat is allemaal goed. gaat wel lukken.
Dat is like de vorige keer. En ik ga nog niet door zijn naar elkaar.
Maar ik ging net zeggen, hoe waren de vorige resultaten dan?
Ik zat ik 17. Ik had iets gevoel dat ik het totaal niet kon. Maar dat andere was 14 en 15.
13 en 15 is niet geweldig, maar is slecht.
Dat is zeker niet slecht hoor.
Dus er komt dan mee.
Het is dat.
Terwijl ik iedere keer het gevoel heb, ik kan dat direct niet, maar uiteindelijk lukt dat ik dan.
Ja, dat is wel waar.
Als je bekijkt,
Dat is wel geen lucht.
6 weken tijd kan.
Ja. Ja, dat is wel waar. En als je het examen overleeft, dacht ik, die in theorie.
Ja, ik zag zo bepaalde zaken.
Wel.
Dat viel wel mee van jou hoor. Je hebt toch 2 keer gezien, dat is dat. Ik dacht van,
Ja.
amai, dat was straf. Want het waren er vorig jaar niet gestudeerd op het examen die het niet wisten. En jij weet dat nu wel zonder, ja.
Ik had het gevoel, ik zit zo iets over halfweg denk ik, van de PowerPoints. Ik had het gevoel als ik bezig was, dat ik daar niks van had, maar als dat hier aan bod komt,
Dat is
dan
ja,
kan
dat
ik
je
dat
dat
wel onthouden.
Nee,
Maar,
tuurlijk.
ja.
Dat is een beetje moeilijk met zo'n type cursus. Hè.
Dus,
Het is niet volledig uitgeschreven, ja, dat is code en bepaalde zaken. Je kunt daar geen veel tekst over schrijven, dat is een beetje het probleem. En sommige studenten hebben nog liever dat ze een volledige cursus dat alles uitgetypt is en dat is makkelijker om te
Ik ken
studeren.
dat ook niet.
Maar code is, ja,
Heel zijn ook.
dan ga je wel tevreden zijn, van structurele is er veel meer theorie.
ja.
En daar ga je echt zeggen van, kun je studeren.
Ik denk dat dat ligt aan het feit dat je uit van de opleiding dat we komen, daar je eigenlijk wel heel veel teksten uitleggen. En je zegt gewoon van op die manier te leren. Het is vooral de manier van leren. Dat
Ja.
ik het moeilijk mee. Je zegt gewoon van te leren met veel tekst. En niet zo, ja.
Ja,
Hier zijn eigenlijk de skills die tellen bij ons.
Maar het komt goed.
Maar
Ja, dat komt wel in orde.
Ja, misschien voor de webtalk.
Ja.
Even